All right.
Good morning, guys. So who here knows what CAD stands for? Raise your hand. So for the video, that's like 5 people. So this talk is on 6. No, you're lying.
A lot.
So this talk is really kind of simple. I call it CAD, a practical approach. This is for computer-aided design, 3D modeling. This is kind of what engineers do and what engineers live and breathe when you're designing things. So if you have an idea, you want to make it solid, make it into reality, first you design it. If you're doing circuitry, you do schematics, you do line diagrams of wires and so forth. If you're an engineer, you're building something, usually you'll put it into CAD. And it could be either 2D or 3D. So who does CAD? So I like this one. What my coworkers think I do, play around all day. My mom thinks I do, thinks I'm like some star engineer, right? What society thinks I do, sit in front of a computer nerd, right? What you actually do, a lot of times people will just do like plant diagrams and stuff. They will just work on like little simple stuff. Kind of when you guys are doing schematics, a lot of people in CAD kind of just do that. You're not ever designing like V8s and awesome like jet airplanes and stuff. Sometimes you are, but that usually takes a little while. So a lot of CAD is really just a tool for you guys to get to what you need to do, which is to build something. So there's tons of software out there. Originally CAD started out as 2D drawings. You take a pencil and paper and actually just draw out lines and do that. Then you want to make it 3D, you had to kind of draw in 3D. And it got a little complicated, a little tricky. So someone went, oh look, we have computers and we can make our lives a lot easier. So tons of software. The big ones that a lot of you guys, when you're in college, you'll see, Pro Engineer, SolidWorks, AutoCAD. Those are probably the 3 big ones. They're easy to use-ish. They're not super expensive. $5,000 to $10,000. Now it's a student edition, $12,000 free for students. SolidWorks, $4,000 or $5,000. Student edition's $100. But there's this big open source movement, and CAD is no longer just for engineers. And it doesn't mean you guys have to use the high-end software as well. Google SketchUp, free, and I think half of you guys are even using Google SketchUp. Tinkercad, another good one. I think they just got acquired by someone. So they were a free software, but the people who did it said, we didn't make any money off of this, we can't support it. I think it was AutoCAD or someone who went, whoa, hold on, we like your open source free software so much that we're actually going to sponsor you guys. So now it's a really good CAD software, and it's kind of designed for 3D printing. Who here is familiar with 3D printing, by the way? Okay, who would here like to have a talk on 3D printing one day and some other manufacturer? Okay, good. So that will come next week, so you guys don't worry. And this is where a lot of this stuff goes to. Blender's a good free 3D software as well, but not so much CAD, but it is good to kind of make models and shapes. So a lot of free software out there. You can Google any of these, find them, download this one, you can download this one, download AutoCAD, download Blender, buy SolidWorks, buy the student edition for $100 if you really need it, and we'll do a demo in it. Pro E, you might see that in college or in your first jobs. I don't like it, but you guys are welcome to use it, just personal preference with all software. So what is CAD Useful? You guys are going to create your projects, right? So you make a little shape. I need to make this rectangle. So you need to do CAD on it, right? But where did that go? What do you do next? So I know what you guys are doing a wind turbine project, I think, right? Yes? Okay. So finite element analysis, kind of a cool thing. When you design something in CAD, what is the point of doing CAD? It's a tool. You're using it to do something else, to teach you something, to learn. So using finite element analysis, you actually start to see stresses and strains in things like wind turbine blades. Computational fluid dynamics. So the car down here, if you want to know the aerodynamics on your car, you put it in a wind tunnel. So you got to get a wind tunnel the size of this room. This is what Boeing does and all the car manufacturers. It's like the size of this room. They stick a car in there. They hook up lots of high-powered fans, and this wind tunnels cost sometimes millions of dollars. They put smokes in there, and they can kind of analyze. And that costs millions and millions. Now with some software that you can get for free, or very little cost, you can draw up your model, get it pretty accurate, and start to analyze and estimate these things. So CAD actually goes far beyond what you guys are doing with just building a couple simple shapes. But it's got applications that just go crazy. Those are a couple of the 2 big ones. So this is something I've worked on. This is one of my product things. And I want to show you kind of what the applied CAD is for. So that's all great theoretical stuff. But how do you guys use it, and how are you going to actually use it in this program? So when I keep harping to my class about technical drawings and blueprints and all that kind of stuff, you need to draw something up. So you get into 3D, that's great. But I'm a manufacturing person, right? I'm a factory worker, or I'm a machinist, or I'm just the guy cutting stuff. I need to know what I'm cutting. So you give me something and say, I need a circle. Okay, how big? About this big. Well, I'm going to go program to my machine, and that machine can go down to 0.00000001 inches. I need to know pretty much, you say something around a foot. Well, 12 inches, 11 inches, 11.5, 11.25, 11.5579. How accurate and what exact dimensions? So you create a blueprint, technical drawing. I have here is a front view. I have a top view, a side view, and a back view. The reason I have the back view here, which is not standard, you have 3 views. Front, top, side. I have a back view because I have this little thing here that I wanted to show. And then I have, quote, isometric view. Not necessary, but if you were to draw this all by hand, you don't have to draw all this accurately, same dimensions, same sizes, and then draw it in 3D. CAD, I make the model once, this all populates. One of the most important things here is these things called dimensions. So I have 3.43 dimensions across the top. That's the width from here to here. If I wanted to cut this out, right, I now know I need a piece that's at least 3.43 inches wide, maybe bigger. Height, 3.5, 0 inches. And there's other dimensions. I have radiuses here, these little curves. I have all sorts of little stuff. These are things, if you're designing your thing, you need to specify this, because if someone else goes to build your project and you don't have those things, they're going to look at it like, oh, that's nice and pretty. Has anyone here found one of their projects where they didn't have enough information in the parts? Yes, 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 yes. Because you don't have enough information, and when that kind of sucks, right? So when you're specifying this and you want to get something made, you need to put enough information. So I'm going to show you what, in terms of this program, what the information you guys really need to focus on. I have a blueprint here. More information, more stuff. I sent this, bless you, I sent this out to be quoted for rubber injection molding. And I need to have a little bit more information on it, and I sent them actually a revised version. Lots of other stuff in here that you guys don't need. But a couple of the main things. If you have your shape, right, you need to cut a block or a rectangle. You want to get your basic dimensions. I need to know how wide it is, how long it is, how tall it is, and then how deep it is, right? These are basic dimensions. I'm going to put a hole, like right here. I need to know what the diameter of that hole is. Does it go all the way through? Simple stuff, but if you ask me to go cut it for you, I need to know those. Otherwise, I'm going to return you a part with only what I see. Title block. You guys don't need to do an official title block, but you need to have some basic information in there, right? You need to know what it is, who you are. This is my company, You need to know the title of the thing, your name probably. Putting a date doesn't hurt, so you know. And then the version. If this is your first version and you have 20 technical drawings, you probably want to have version 1, version 2, version 3 so you can keep track. Now, who here is familiar with significant digits? Good, most of you. So when I didn't have a dollar caliper. When you're measuring something, right, or you're drawing it, I wrote to 2 decimal places there, 2 significant digits, 3.43. That means that I don't have a 3rd digit at the end of the top there. That means that this dimension, when you cut it, if it falls within 3.435, 3.432, 3.436, that's all within the tolerance I specified, right, in terms of significant digits. In CAD and engineering, it's a little different the way you term out your significant digits. You don't just say, all right, I'm going to put the 5 decimal places, and that means I only have that last decimal. It can only go plus or minus a little bit. You actually say what your dimension tolerances are. Right? So if I'm building something like, I'll give an example the other day. I'm building a house, right? And I'm laying out my beams on the floor. I'm going to say it's around 42 feet plus or minus a couple inches, right? It doesn't need to be too precise. Do I need to get it down to 0.001 inches, which is like less than your human hair? No, and you can't. So you give it tolerance. I'll say, make it 42 feet plus or minus 1 or 2 inches. So here what I did is I actually specified out the tolerance. So anything that has 2 decimal places, I said plus or minus 0.015 inches, or 15th thou. This is important when you're getting your stuff cut. If you want to know how precise it needs to be. If you don't know how precise it needs to be, pass. It's not too complicated. A lot of times in technical drawings, people will put 1.8200, 4 decimal places. The machinist goes, I cannot hold a 10,000th of an inch, which is like slicing your human hair up many, many times. You just can't hold that cutting metal. Expands, contracts. Cutting wood, not going to happen. So a lot of engineers just go crazy with that. So for you guys, keep your stuff simple and put a simple tolerance on there. Or say, I need it to be 3.0 inches plus or minus a 16th of an inch. It's not super precise. Or that needs to be super precise because that's fitting in between this one little spot. So those are a couple things you need to keep in mind. And feel free to ask us any time if you're like, does this look right? So, how does it get used? This is a picture out of Tinker CAD. When people draw this stuff up, this is, you guys kind of look like an Arduino board, right? So,
Rather high.
or Raspberry Pi, my bad. Thank you. But they designed a case. And the case, they had the basic dimensions, but when you take your 3D, where it goes next, especially for you guys, some of you guys have 3D printed parts, I need to have this thing modeled done. We need the technical drawings with those basic dimensions, and we also need the design in 3D accurate so we can actually print it. Now, let me show you a quick demo of what some CAD looks like, as long as this thing works properly. So this is SolidWorks. This is SolidWorks. And like I said, this is professional level, student edition. This is one I play with at home for once in a while. And you can do all sorts of stuff with it. I'm going to mouse a second to calibrate. It's kind of simple. So we're going to do a new part. I just want to show you what it looks like. So SketchUp, all the CAD softwares are very similar in terms of what they do. You draw parts. For instance, I have these planes here. Everything's in X, Y, Z, and it's always in 3D. When you draw, you usually draw in 2D. So I'm going to say pick the front plane, and I'm going to start a sketch. I want to draw on this plane. In SketchUp, all these things are very similar. SketchUp's a little easier to use. This takes a little more input, but the more input means you have more control and more accuracy. Say I want to do a cylinder. So I'll make a cylinder. I'll put it in the center. It's roughly that big. How big is that? I don't know. Well, but I know what I'm building, right? I need this to be 2.5 inches. So I'm going to make this, and that's the 2.81. I'm going to say 2.5 inches.
Is that the circumference or is that the
Diameter. So look at where the bar goes. It goes across the width of the circle. So this dimension is really simple. It says from here to here is 2.5 inches. A lot of CAD works that way. It's kind of simple. It makes it easier versus having to have like 5 different types of dimensions. You can do like a certain, can't really do circumference. I'm not entirely sure you can use circumference on here. But for the most part, simple dimensions. And say I need to have a round, squarish hole in the middle. Actually, let's not do that one. Let's do this one. And again, with the more advanced CAD, you get to do some cooler things like this. So it has a center aligning rectangle tool. I'm going to make these guys equal. So these guys are the same exact width. And you guys please don't memorize any of what I'm doing here. This is just kind of show you what it looks like to design in CAD. So when you're doing SketchUp and so forth, this looks familiar. Make this 1/2 inch. 5. And I'm going to, and this is what traditional AutoCAD type CAD looked like. You would just draw in 2D. And you'll see in a second what this becomes. So let's do a fillet. Let's make this 0.025. Do this corner. Yeah. This corner. Yeah. This corner. Sometimes you get errors, and I just usually ignore them because I don't even read them. If it doesn't work, it doesn't work. I figure out another way to do it. You know, the whole problem solution didn't work. You figure it out. You learn. So I got these little corners now that are allowing me to have a little round. Because when you're actually machining and cutting things, the cutting tools aren't square. They actually cut little rounds. So you want to think of that in mind as you get further along in your futures. Good. Now, I have this thing. It's just 2D. It's just thin lines, right? So what I'm going to do is say I want to take that shape and I want to make it into 3D now. AutoCAD works very similar to this. SketchUp kind of similar as well. Some softwares, you start out with like a box and you kind of reshape the box into what you want, or reshape a cylinder. This works the other way around. You start with nothing, you draw it, and then you make that into the thing. Call it like additive CAD. Grab a little guy, make it, let's do 1 inch. I can't do that accurate, so I'm just going to type in 1 inch. Right. Good. So now I made that little shape. Say I need this thing, and this is, so you can kind of see the shape. Now it's pretty simple, just a cylinder with a hole in the middle. But I need this machine, right? I need this machined out of metal. And I need to have this done for my project because it's creating a washer thing. Here's the next thing I want to do. So I'm going to take the other plane, which is this way. I'm going to do an extruded cut. And realign. And we're going to make it up now. Let's say I need this to fit over another round cylinder. And I need this to fit over another cylinder. So you start to learn how these design software work, and through all. I'm going to do the other direction, so it's not going all the way through, it's only going halfway cutting through. So I'm going to hit the second direction through all the other way. Okay, let's see what happens. Ta-da. So now I've made essentially a little washer that has, actually a large washer, but has an opportunity to fit over another shaft. So say this has to fit on a round piece. And I need that washer there to hold and align a little square piece of metal that goes in there. Something simple, right? That's all I need. Take that, and if you're in this kind of software, you can go right to drawings. If you guys are not, you can draw your drawings by hand on paper. Eventually, I want you guys to use the CAD though when you're doing your drawings for your technical drawings, when you upload your final deliverables. You can have a sort of simple technical drawing. Let's call this test 1, test 2. Good enough. You want those simple information, the dimensions, the title block, that's about it. But you want to be just like your project you document, you want them to be able to build it from what you have. So if I read through your stuff, I should be able to build your project, just like the instructables and the things you have. If you can't, it's not good. So let's do blank. Alright, so I'm going to do it as if you guys are doing it something else without the title block, all the fancy stuff. I want a few simple things here. The diameter, and here's where it uses the diameter symbol option. 2.5 inches. I'm going to need, I don't know what that is. I'm going to need this guy here, this dimension. That's not going to work, that's not good. Hold on. We're having technical difficulties today. I changed something by accident, and now it's not working. We're going to edit this out of the video.
Good. It's funny.
It's not funny, it's difficult.
It's hilarious.
Well, so all I want really is these 3 views. Let's see if we can get some of the other dimensions to work. But the critical ones here are I need to know the overall, that guy. We'll probably need to know this guy, the width, about 0.5. And then I don't know that this thing is square, right? Nothing told me it's square. So you have to specify that it's square, either by saying square or by saying 0.5, 0.5. Because it's all centered, but I might not even know that's centered. We'll assume it's centered. Overall thickness. Yeah. Sometimes you cheat. Do this. So cheat because it doesn't let me do this into this software. But each software is different. And now I know when I start this block to go machine it or make it. I got a little hot. But you can start to see that I need to have it 1 inch, 2.5 inch diameter, and so forth. In terms of the notes you want, something simple. Name, date, version 1, rounded washer, and then if you want to get fancy, because these are good drawings, material, steel, 304. Okay, simple. And then you're done. Go and print that out, make a PDF, put that in. Now if I go to build it, if I want to build this thing, I have enough information. CAD is kind of dry, it's not super exciting, we're not making V8 engines, but this is enough of what you need to get started to make your thing. So if you want to get something made, and you want to do it right, document it well, this is a good start. Questions?
If you make a design in there, can you just use that same exact thing that you made and send that to a 3D printer?
Usually. So design for 3D printing, this we'll talk next week, is a little different. So this part might 3D print well, might not. But yeah, you can use the same exact model. That's why I like to do it in 3D first, because then I can go right into drawings, blueprints, and 3D print, or send it to a company that does, say, machining, and they can go and take the 3D file and just machine straight from that. They don't have to redraw off my blueprints.
Wouldn't it be much easier and more accurate if they were just able to use like that file with the 3D model in it than to have to look at blueprints?
Yeah, but a lot of times you can use a 3D model, but by doing this blueprint here, in manufacturing, they'll take the blueprint, they'll make the part's not going to come out to that blueprint perfectly. It's going to be that 2.5000 is not going to come out to that. It might come out to 2.508. So use the blueprint as a way to check to say this is what it's supposed to be. Because the 3D model, it's all vector kind of based, so the numbers come out exact. It's 2.500000000. I don't know how accurate that's supposed to be. By putting it into a blueprint, I can then say this 2.50 is going to have a 20th thou accuracy, or a 16th of an inch accuracy, or an 1/8 of an inch accuracy. I don't really care. It could be an inch bigger. It doesn't matter to me. So by putting that in the blueprint, you then specify that. Ideally, you work off the 3D model, especially when you're machining it. You just toss it into their software. They machine it straight off your model, and it comes out as close as theoretically possible. But materials in reality don't come out that way.
Do you put the blueprint or the 3D model directly to the 3D printer to get it to work?
Usually.
Or?
I won't use the blueprint. I'll just use that 3D model I had a minute ago. I'll just use this guy, and I'll just save the file type a little different and 3D print it.
What are some common dilemmas you face when using this CAD?
Crashing.
What do you mean by crashing?
Software crashes. So this software is processor intensive, crash intensive sometimes. SketchUp, same. They try to make it as lightweight a program as possible, but it has a tendency to crash, tendency to use up all your memory in your computer, so you'll have a lot of issues that pop up. A lot of times I'll want to draw something that I can envision, but I can't do in reality. It's so hard to do. The nice thing is though, you can figure out ways in CAD, like the problem solving approach you guys are using, you can actually kind of like, alright, how can I figure out a new way to draw this up? The hardest thing and the biggest thing you guys will face as engineers, and if anyone goes to mechanical or civil, is you will draw something that can't be built. It's very common, and a lot of engineers go, but I drew it that way, how come you can't build it? And the guy goes, because this is impossible. It's the hollow sphere. How do you make a perfect sphere, no seams, no edges, no glue together? It starts as a solid sphere. How do you take away and make it hollow on the inside? How do you do that with any manufacturing techniques we have? No one can say 3D printing, that's cheating now. But back in the day, this would be the first machinist questions, how do you make a hollow sphere? And then people would be like, well, I can draw it, I can do it in 3D, it's really easy. I just do one sphere, I do another sphere, take it away in the middle, and I have a hollow sphere. Make it.
Oh, I know how to do it.
How?
Okay, well, you can make a sphere that's not hollow, and then you can like have like a little
Tell people this.
like a little stick, and you can make it very hot, so it starts a fire on the inside and it burns it, and
Where
then
does
you
it
take
go?
it out, and then you like pour water in it. It's kind of hollow.
I totally lost you.
But then you have a hole in your sphere.
Basically, you burn out the inside of your non-hollow sphere, and then there's a little hole where you stuck in the match or whatever.
So you have a little hole in the sphere though.
No, and then you cover that up with like wood adhesives. Like there's this
Like
thing.
glue?
No,
Like filler?
not yeah,
Like wood
filler.
putty?
Yeah, that
Yeah.
stuff.
So, but that now you have one material and then you have a hole with another material in there. So it's not perfect.
Fine, so you can just make a little circle of wood and stick it in there and glue it there.
Yeah.
You could make a mold and then pour like molten like steel or not steel, like iron in there or something, and then it'll form like around the mold if you put like a sphere in the middle. So it would make like it would like solidify in the shape of a hollow sphere without making any.
Yeah, that's true.
Yeah, but then what would you do with the mold?
Also,
Yeah.
how would
You
the
could-
hollow
you-
sphere be
yeah,
attached
no,
to the
he's
side
right.
of the mold?
You can
have
take
an
a
That's
escape.
be on the mold.
Magic.
Floating
You need a special thing
So
that
you need
like
floating spheres and you need magic. So this is one of the things that I can draw a hollow sphere in 10 seconds, right?
We'll count, we'll time you.
10, 9, 8, 7, 6,
Computer
5.
You can draw a hollow sphere. Can't necessarily make it easily, and that's probably the biggest challenge that engineers face is they can draw it, they can design it, but you can't build it. And that's one of the things. The practical approach to CAD is make something that you can draw something you can make.
How do you know if you can make it or not?
You go try and make it, and you learn the hard way that you can't make it.
You spend hours and hours on something and then like,
It's really difficult and it really sucks, especially when you're at your job and you're like spending 5 weeks on a project and everyone loves it, and then you send it to the shop to get made and they're like, yeah, we can't make hollow spheres. And you're like, but I drew it. And they'll be like, but we can't make hollow spheres.
So how do we have hollow spheres now?
So you 3D print, you can do a hollow sphere.
No, but like, you know, like those plastic little balls that you have as a kid.
Ping-pong balls?
They have seams.
They've seen.
Let's see where seams.
Seams? Like on my clothing here, I have like a seam here.
Like a baseball.
But why are seams cheating? You can use a seam.
Because the idea is how do you do it out of one material without.
So it's not
So you make a
impossible,
mold.
it's not impossible.
So it's not
Not
possible. Yeah, use a seam. It's not possible. Use a seam.
Okay, you guys are now.
No, but then you said nothing's possible in this. Oh,
No.
you said like nothing's possible to make perfect.
Well, you can't make perfect. So if I make this is perfect, right? It considers it to infinite decimal places of perfect, right? When I go to machine it, the materials can expand and contract. It's going to change a little bit. My cutting blade's a little off. You know, all those little things. You're never going to get as perfect as in theory. With anything, there's never going to match theory.
That's not perfect either. It's made of pixels.
But
Oh, there you go.
the calculations behind it are all vector based, and they're all based on like
Yeah, but there's not
line
in-
equations.
There's not an infinite number of pixels, so maybe it should be in between the pixels. But it's
So
actually
any
not.
questions on using CAD in terms of making your projects? Yes, John?
Do you have any good tutorials or like good like cheat sheets to use?
There's a ton of good tutorials for SketchUp, SolidWorks, a lot of YouTube stuff.
So you're using SolidWorks?
Yeah,
Is
this
this
is
a
solid.
$100 one?
Yeah, might be 120 now with a student license, 1-year license. I would recommend starting with Tinkercad. With SketchUp, they're free. With the AutoCAD is free. SolidWorks is terrific for 3D modeling and design, especially when going into making parts, 3D printing, machining. It's more of like used on the smaller end industrial scale.
So like if you have something, who would you send it to?
Me? If I want to quote it or made on a low end, and I didn't really care who did it, I'd send a proto mold. And this again will be in the other talk with the rapid manufacturing. But they're a company where you send your model or your design in, and then they go and make it for you, send it to you. So I send something in today, a couple days later I get back my 3D printed or machined part. So
You don't have to buy like 1,000 of them. You can just get one.
you get one. That's their specialty. They do just one. Otherwise, if I wanted to call up a manufacturer in China, I'd be like, hey, and they go, okay, the only way we're going to set up our factory to do your part is if we do 100,000. And that's what it costs a lot to get stuff manufactured. The whole point of rapid manufacturing nowadays is that you can do 1 or 2 and save a ton of money and get your thing made. Proof of concept.
Is it expensive?
It's a little more expensive to do 1 versus if you did, you know, if I'm doing 100,000, you get economies of scale and I get 1. But then you have to buy 100,000. Any other questions CAD related? No.
How much money can how 3D printer works?
Huh? So
Yeah, can you bring in your 3D printer?
I will try and bring in my 3D printer.
You have a
there's a
3D
Yeah, there's 3D
printer
printer here.
Oh, there is one?
Yeah, I am
Where?
like in charge of it here in the
some
school.
students from the school built one.
Yeah. There's a kid named Avi Schwarzschild, whatever. He built one,
And
and then he passed it on to a bunch of other kids. So now me and like 2 other kids are in charge of it. It's in the, it's in that room which is locked, so we can't get in
So what's the use of it?
unless like David's Law comes or something else.
So I can try and bring my 3D printer. It's not too big. It's about yay big. And we
Pretty
can do
big.
a demo, and then we'll explain what 3D printing is and show you guys some more other
What will we
manufacturing
print?
techniques.
Yeah, there's
What we print? Hollow
Can
spheres.
we make a gun?
No, we cannot. And we'll edit that out.
Yeah. The Liberator.
No.
Liberator.
No.
Yes.
Any other questions
And
relevant
then we
to
can
today's
3D print
talk?
bullets
It's like
That would be so
and play airsoft.
Alright guys, thank you
So
very
fun
much.
to play with.
Okay, sorry.
no, it has
I have a question about 3D printing.
it has